Sri Lanka is a tiny island nation located in south of India, in the Indian Ocean, and is a rugged landed rainforest, diverse wildlife, and endless beaches. Sri Lanka climate is tropical and consists of wet and dry seasons. Payula monsoon brings heavy rainfall to the country's western and southern regions from May to September. The southwest receives around 4,000 millimeters of rainfall each year. The Moha monsoon affects northern and eastern Sri Lanka weather and often lasts from October to January. This region receives approximately 1,000 millimeters of precipitation annually. However, in monsoon season receiving water more than the adequate quantity, in the dry season, the water is not sufficient to fulfill the requirements. In monsoon seasons, a large volume of water flowing through the rivers to the sea. To solve this problem, the concept of constructing reservoirs, anacuts, built up even in kingdom periods for storing the excess water. In the present, mostly the responsibility of construction such massive reservoirs is undertaken by Mohali Development Authority. Being the longest river in the Sri Lanka, Mohali Development Authority raise massive reservoirs, crossing the untamed Mohali River. Crossing water of the Ambunganga and Kaluganga, another two huge dams rise under the Moragahakunda Kaluganga project. Moragahakunda Kaluganga development project is one of the largest reservoir projects to be taken up for development under the Mohali Development Authority. It is located in the middle of the Sri Lanka, Marthal district. Stand not only for two massive structures, but also arouse the eyes of expectation of North Central and Northern Provinces people. Employ part of this project is done by Ministry of Mohali Development and Environment. Central Engineering Consultancy Bureau CECB has been executing the consultancy part. One of the largest hydroelectric company, Sinohydro Corporation of China, has undertaken the construction works of this project, collaboration with Power China Company. Kaluganga Main Dam is a center lake or rock-fill dam, which is raised up to 68 meters, having an extended length of 618 meters. It is recorded among the longest dams in Sri Lankan history. There are different types of materials are used for constructing the dam in order to maintain different factors. Those are transition material, rock-fill material, filter material, core materials, and finally riprap material. Transition material including finer of 75 mm particles. This material applied to adjust stress of adjacent zones to each other. Rock-fill material is taken from the quarry areas. It provides structural support for the core and distributes the load over the foundation. filter material consists of crushed rock particles which are less than 8 mm in size. The construction of the sealing core zone within the dam embankment shall consist of cohesive soils available from selected borrow areas. This area will be well compacted layer by layer after loading, and this layer helps to hold back the free water from the dam. Finally, a riprap layer is provided to cover the upstream face to prevent erosion or wash by waves. This is a cross-section of the main dam. When water fill in the reservoir, water seepage through the fractures. This is not acceptable, which means we should use curtain and blanket grouting. Curtain grouting go deep into the bedrock. The depth of the holes maybe changes with the conditions, so grout is applied with high pressure to fill all cavities. If not test results satisfied, secondary, tertiary, quaternary holes add until lesion values decrease to a satisfactory level. Kaluganga River has to be diverted during excavation and construction of the main dam. Diversion tunnel is the perfect solution. After the upstream coffer dam constructed, river is diverted through this tunnel, and then the downstream coffer dam built to prevent the downstream water going back to the dam site. The tunnel design and construction performed under the Neustrian tunneling method. Prior to the tunnel excavation, consolidation of the portal area is essential, so slope supporting and forepoling works are done. Tunnel excavation is carrying out by conventional drilling and blasting method. Just after the tunnel face advances, temporary rock support should be applied. Rock bolt installation is done immediately after the blasting. Spraying shotcrete is done to consolidate the weak area. Before plate installation for rock bolt, wire meshes fastening is done. The number of rock bolts on the peripheral of tunnel changes with rock supporting system. The rock supporting system is determined by rock mass rating. This rating directly gives the idea of rock condition. Shotcreting should be done after the installation of wire mesh. This also settles the excessive rock deformation. Applying shotcrete layer thickness changes according to the rock support system. This procedure will stable the rock near the tunnel face, because cracks propagation is destructive around the tunnel face. Before pouring screed concrete, dust, dirt, detached areas, rubble and any other material or substance on the surface of the screed must be removed before installing the flooring. Once the cleaning was completed, work was started on screed concrete on the floor and finally the invert concrete. Reinforcement work is done according to the approved drawings. Structural steel work such as cutting, welding, bending and binding is performed in this process. Subsequently, as a permanent rock support, pouring lining works is done from the bottom to the top of the tunnel face. Pouring of concrete easily be done using lined pump cars. By adjusting, removing and adding the specially made pipes, concrete poured into the required position. Diversion Tunnel, in short DT, is the largest tunnel built under this project. This tunnel 384 meters long and internal diameter of 10 meters. This is the commencement of the BO tunnel. Water flow through this tunnel after dam construction completed. With the end of the BO junction, plug will be installed to seal diversion tunnel. On the left bank of the dam, stand for one of two shafts constructed for this project, and that is bottom outlet shaft. BO shaft performed as a surge tank which absorbs sudden rises of pressure. Also, this design control water flow for maintained purposes. At the bottom of the BO tunnel, there is a gate which seal water flow from the reservoir. But when necessary, gate raise up and release water flow to the Kaluganga. BO tunnel directly joined to the diversion tunnel before the plug area. The significance of this tunnel is to feed water to the river for the irrigation purposes. Additionally, this is used to remove mud and silt particles from the reservoir. Considering the water requirement of downstream of Morriga Akanda Reservoir, TCO Tunnel release additional water quantity to the Morriga Akanda Reservoir annually. LBO Tunnel provides water for irrigational purposes in the downstream of left bank of the dam. A spillway is a structure used to provide the controlled release of flows from a dam into a downstream area. So spillway prevent damages or even destroy the dam. A number of velocity-reducing components can be incorporated into their design, such as chute blocks and end sills. This spillway includes 3 chutes, and for each chute there is 1 radial gate. Width of each gate is 8.8 meters and radius is 12 meters. Once water reservoir comes to its emergency level, radial gates open and release excess water. A stilling basin at the terminus of the spillway serves to dissipate energy and prevent erosion. This massive structure needs a large amount of concrete, technically mentioned as a mass concrete. To control temperature gradient and core temperature, a cooling pipes are installed before pouring concrete. Boom concrete pump cars are used to pour such massive concrete volume into blocks. Saddle Dam is located at a fairly distant away from the main dam. Saddle Dam is an auxiliary dam constructed to permit a higher water elevation and storage, or to limit the extent of the reservoir. The height of this dam is 28 meters and the length stretch up to 720 meters. The construction of the Saddle Dam is done separately from main dam works. Excavation of Saddle Dam is begun according to the reports given by the surveyor, and construction is performed under the instruction of engineers. Additionally, right bank irrigation outlet is located at the Saddle Dam for the irrigation purposes of the right bank of Kaluganga. In the near future, Moragakanda Reservoir will supply excess water to reservoirs in Northern Central Province. Therefore, people will benefit by having adequate and continuous water supply. As a result, this phenomenal project will fertilize crops, paddy fields, and bring back happiness and dormant smile of lot of people.